Hey everyone, welcome back. In the last video, I showed you how to go from a simple airfoil to a full UAV concept design using just a couple of horizontal sketch lines. The feedback on that video was incredible, so thank you. I promise I'd address your questions and take this design to the next level. Today, we're diving into your structural questions and bringing our drone closer to flight. Let's have a look at the questions. One viewer asked, I'm looking for guidance to what is done after this to convert surfaces into solid parts and used for 3D printing. I'll show you this and we'll analyze the center of gravity of the model and apply some custom material. Next question is, what about organic wing shapes as well as wing twist? For example, the trailing edge or the tip fall raised a few millimeters higher than the root, and then guidelines to create more fun shapes. I don't know if this is possible with the profile generator. We're confirming that the profile generator can be used for these complex shapes. We'll work on the model to create a dihedral angle, define a swept wing, plus washout twist. We will parametrize these variables. Another viewer asked, also, it would be cool to see how you plan and model this drone for simple assembly, disassembly with connections and clearances, as if someone were trying to turn this into a portable glider, for example. So we're focusing on design for assembly by modeling the ribs for the wing structure. Let's see how Onshape's powerful pattern feature can automate that process. So this sets the agenda. Now let's dive into the CAD and solve these problems. I will continue with the model from where we left at the end of the last video. I've placed a direct link to the Onshape document and the video in the description so you can follow along. So there is our surface of the entire drone, and I will convert that to a part. See, we don't have any parts yet with the enclose command. I'll just window select everything and there's our part. I'll assign a material to our part. And I want to show you how to create a custom material. Let's say we want to use extruded polystyrene for this, maybe for hot wire cutting production. So I place XPS as the name and apply the 0.04 gram per cubic centimeters. And let's calculate how what the mass is, 134 grams, and let's see where our center of mass is. It's here, 228 millimeters in the y direction, almost at center of the root wing. Okay, let's keep that in mind. For now, I will suppress the enclose to continue working on my surface. I will go back to half my model. And let's go over to that second question about changing wing characteristics. First, let's work on that root plane for our wing and define a root angle. So our sketch for this is here. we had to define the profile generator with that plane number 1 here. But I want to modify that. So let's go to sketch number 2, roll to here, make that line visible, then go to the plane command and take that line and maybe apply an angle of 86, and we want to make this defined by a variable. So I go one step back, take the variable command, go to angle, call that root angle, and apply that 86 value. Then I'll define that here. Root. Okay. And for that profile generator, I need to edit the plane to plane 8. All right. So that is our first loft from that fuselage. Then we had defined just a plane to cut through our model. But the next plane is this one. So we had defined plane 3 as an offset from the right plane, and we'll reassign that to this plane here. Okay, I'll create a new variable for that distance. Now I want to show you the variable table. Makes it easier to work with variables. I'll name the next one wingspan, length, and apply a 866 millimeter value to that. And define the offset distance here. Okay. So here we had drawn that line with a coincident constraint to that point. Now we want to define a swept profile, and for this I need a line which defines the angle of this. So I'm going to sketch on the top plane a construction line at some angle. I'll attach that to our plane here and to that initial vertex here. Now let's define that variable for that, swept profile. So that's going to be an angle. First I'll assign 88 degrees. No. 88. And now let's take that line and maybe to that very first sketch line, define that angle. All right. So this is, I did this right before that sketch number 3. And we need to reassign the constraints here. So this won't be coincident anymore with that endpoint here. I'll erase that constraint. Now I'll apply a vertical constraint from that endpoint to this line. I'll project that root line, make that a construction line, erase that horizontal constraint, apply that coincident constraint, and define an angle here by the next variable, which I'll call washout. This is an angle. I'll give that 4 degrees and apply that washout. Okay. Now I need a loft this. P hides all planes. Shift H all sketches. And well, let's see how this works. First, I'll work on that angle here. Maybe change that to 84. This works. Then change the length with 822. Okay, jump right back. Then the swept profile, go to 84. All right. And then one more. Okay, we can see that this works. We can see the washout. I'll just change that to 6. And there we go. Great. I will now address the question about how Onshape can help me with assembling, and I will focus on the wing and here on a rib structure. For this, I will first define 2 more variables. The number of ribs on one wing. So I'll start with 12. And then the distance between each rib, I'll call that value offset distance. This is a length. And this time I will calculate this by the wingspan divided by the number of ribs. All right. I'll go back to that plane. We had just defined the plane number 8. And I think I want to make this our next loft independent from our fuselage. So I'll make that as a new surface and maybe hide the fuselage to make things easier to see. So I will define one plane from that one with an offset of that offset distance. Okay. Now I will create a curve, an intersection curve between our surface and that plane. There's that. Let me hide that our wing for a moment. I will fill this curve with a surface, number 3, and then thicken that with the midplane and a thickness of 4 millimeters, 2 to each side. Great. Now I'll create that pattern of those ribs, but not as a part, but as a feature. And there I can include a plane as a feature, that intersection curve, the fill, the thicken. The direction of this is obviously our root angle plane. Now the distance will be that offset distance. The instance count will be the number of ribs. And let's accept that for a moment. And we see that it's reproduced each instance, each rib as the initial one. But that is not what we want, and Onshape can do more. It can reapply that feature. So what does that do? So each instance is calculated at its exact position on our wing. Let's just play a little with the numbers. I'll get a number of ribs and make those 22 ribs. And perfect. Then I'll just change the washout to 9 degrees, just as well. Let's have a look how the twist is being calculated on each instance. Well, maybe with a different root angle, 74 degrees. Let me show the surfaces here. Then the swept profile, I'll go here to 88. And everything works perfectly. I include a link to this document as well. And that wraps up a massive session. We've covered a lot today. We showed how to transform a surface into a solid part with accurate mass properties for manufacturing, how we parametrize our wing design for easy iteration, and finally, how to create a clever rib structure designed for simple assembly and portability. If you want to access the full features needed for professional design, you can get your free professional subscription through the exclusive link provided in the description below. I'm also including a direct link to this exact Onshape document so you can dive in and reverse engineer the features yourself. Thanks for watching and for all your great questions. Hit the like button I'll see you in the next one.